Kind of a fun one, all right? For a certain sequence of numbers, the sum of the first n numbers in the sequence is given by n to the third plus n to the plus 4n for all positive integers n. What is the 10th number in the sequence? So we have all of these numbers. We have 1, 2, 3, all the way down to 9 and 10. All right. What we need to know is, well, all of these from 1 to 9 and then 10 all add up to n to the third plus 4n. Well, if we just plug in 10 into this, so we have 10 to the third plus 4 times 10, we get 40, 10, that adds up to, but we need just the 10th number. That's what it adds up to. So let's make another row of things that it adds up to, all right? And I'm gonna actually put this 40, 40, sorry, I messed up there. So 40, 40 in that box there, all right? And we need to figure out what that number is, that last addition to get 40. Man, I keep messing up. Sorry, guys. This is 1040. All right, we have 1040, because this is 1,000 plus 40. Okay, I think we're on the right track now. So let's just see if we can find a pattern in this. Well, let's try to plug in 1 and figure out, if we go down the sequence enough, if we can find a pattern. So if I plug in 1 and I have 1 to the third plus 4 times 1, well, 1 plus 4, that's just 5. So these are my sums, and these are my numbers, my numbers in the sequence. So, well, we know that that sum means that we have the numbers before it plus that equal 5. Well, we don't have any numbers before it except for 0, and that will give us 0. So we know our first number in the sequence is 5. Let's try the second one. If I put 2 in here, 2 to the third plus 2 times 4, well, that's 8 plus 8. So we have a sum of 16, which means that this number and this number need to add up to 16. Well, 5 plus 11 add up to 16. So my second number in the sequence is 11. Let's try it one more time to see what we can figure out. If I do 3 to the third plus 3 times 4, that would give me 27 plus 12, which is 39. Well, we know that this number and this number and this number have to add up to 39. So we have 5 and 11, which is 16. So, and then 16 plus 23 equals 39. Well, actually we can see that another way too, because this is the sum of those two numbers. So 16 plus 23 equals 39. Or we can look at it as 39 minus 16 gives us this number, 23. Well, it works here too. If we do 16 minus 5 equals 11. So we can say that when we get up to 10, we could do 10, the 10th sum, minus the 9th sum to get our 10th number. So all we really need is this number right here, our 9th sum. And that's something that we can figure out because we can just plug it into our sequence, into our equation. So that we have 9 to the third plus 4 times 9. Well, if you multiply out 9 to the third, that gives you 729 plus 36, which gives you 765. Well, just like we did here with 39 minus 16 equals 23, we could do 1040 minus 765 will get us our 10th number. So 1040 minus 765, and that gives us 275. And that is our 10th number. If we were to work backwards and actually figure out all of these numbers, we would find that 5 plus 11 plus 23 plus the next one and next one all the way up to 10, our 275, would all add up to 1,040. And that's our answer. Our 10th number in the sequence is 275. Okay? Let's keep going. All right. Number 19. The figure shows a square in the interior of a regular hexagon and sharing a common side. What is the degree measure of angle ABC? So we're looking at this degree angle right here, ABC, that one. Well, let's look at this. First, we need to know how many degrees are in an angle for a hexagon. Well, we have this nifty little equation that we can put it in. We have 180 times n, the number of sides that we have, minus 3, divided by the number of sides. And that will give us the degrees that we have in each angle. And as you can guess, I have 180 and 6 minus, this should be 2, sorry about that. 6 minus 2 over 6. Well, I'm going to simplify because I don't want to multiply out 180 times 4 and then divide it by 6. So I'm going to simplify and do, well, I can get 6, I can get 1 6 into there and 36s into there. So 30 times 4 is 120. So I know that every angle in here is 120. Well, let's see what else we know. This is a square, so I know these angles are 90. Okay, so if this whole angle is 120, then we can say that this angle, the small one, is just 30 degrees. Okay, because 30 and 90 give us that 120 that we need. The trick with this question is seeing that we have a square here, which means that this side is congruent to this side. Well, if this side is a side of the hexagon, then we can say that this side is equal to this side and congruent because it's a regular hexagon. So by seeing that, we see that these two are congruent, which means we have an isosceles triangle. So that when we do our 180 minus 30 to see how many degrees we have left, we have 150. And if we divide that by 2, because we have 2 of those angles, we see that it's 75 degrees in each one of those. So each one is 75 degrees. Well, if we're still adding up to 120 for that whole angle, 120 minus 75 gets us 45 degrees. And that's my answer. 45 degrees. Great. All right, let's look at number 20.